Hello, everybody, and welcome to our lesson on section 17C, optimization. So optimization is another application of calculus, and basically there's many problems that we need to find the maximum value or the minimum value for. And that solution is called the optimum solution, or the process of finding it is called optimization. Now, optimization is one of my favorite topics because it's something you've been doing all throughout high school. You've just learned different ways to handle it based on the math that you knew. So back in grade 9, if you were trying to optimize something, like trying to find the maximum area that you can enclose with 60 meters of fence, then you might have used technology or made graphs of the function and looked for the max or min value. You might have made a table. In grade 10, you might have used the formula x equals negative b over 2a to find the vertex of a parabola, if you're trying to find the minimum or maximum value there. But now we're going to use calculus to help us find the turning points of the function. Okay? And just a warning as we move forward, you have to remember that when we're looking for the maximum and minimum points, we can find them using calculus, but we also need to test endpoints. So we need to consider that the maximum or minimum value does not always occur when the first derivative is 0. Sometimes the endpoints are the highest or lowest that a function ever gets. Okay, so just as review, the second derivative test, remember that the second derivative test tells us about concavity. And if we know something is concave up, then we know it has a relative minimum. If the function is concave down, we know it has a relative maximum. So in other words, if the second derivative is positive, then my function is concave up and we have a minimum. If the second derivative is negative, then my function is concave down at that point and we have a local maximum. And if it's equal to 0, the second derivative test fails, and we have to use the first derivative test to determine what we have. Okay, so this is a discussion question I usually do in class, but I'm going to skip it in the interest of time. So we're just going to review quickly. If I just gave you a question like this and asked you to find the absolute max and min of the function on this interval, I'd start by taking the derivative of this function. I would get 3x squared minus 3x. I'd set it equal to 0, and I'd solve for x. And I'd get my critical numbers, which I'm going to use in my sign chart. Okay, I'm going to put those numbers into my sign chart. I'm going to include my two endpoints, -1 and 2, and the two critical numbers that I found, or turning points. Okay, and I'm going to check. If I plug in a number between -1 and 0, like -0.5, this value is going to be negative, and this value is going to be negative. So overall, I'm going to get a positive result, indicating that my function is increasing at that point. Between 0 and 1, I could pick a number like 0.5. This would be positive, but this would be negative, which would give me an overall negative result, indicating that my function is decreasing at that point. And finally, if I pick a number between 1 and 2, say 1.5, this value would be positive, this value would be positive. We'd have an overall positive result, indicating that my function is increasing on that interval. If I'm going from increasing to decreasing, it suggests that we have a maximum when x equals 0. And if I'm going from decreasing to increasing, it suggests that there's a minimum when x equals 1. Now I need to test the potential maxes and mins. I need to find out, this is where horizontally I have a max or min, but the actual max or min value is determined by plugging it back into my original function. So if I plug in when x equals 0, I'm going to get 0. When x equals 1, I plug it into this function, I get -1/2. I'm also going to test my endpoints, so I'm going to plug in -1 into my function, get -5/2, and I'm going to plug in 2 into my function, and I'm going to get 2. So notice that -5/2 is the absolute minimum. It's the lowest that my function gets at -1 and -5/2. And 2 is the highest that my function gets. We call it the absolute maximum. That happens at 2, 2. Okay, and last, just notice I only used the first derivative test here, but if I applied the second derivative test, I would notice that when f double prime of 1 is equal to 3, and the second derivative evaluated at 0 is -3, which just confirms that x equals 1 is a minimum and x equals 0 is a maximum. Thank you, and we'll continue in the next video.